Hello class, today we're going to talk about special right triangles. This is the first lesson of a 3-day lesson, and what I'm going to do is I'm going to create separate videos for each particular concept that we're talking about. So today we're going to be talking about two such special right triangles, the 45-45-90 and the 30-60-90. But first, let's review what we know about right triangles. Here's a question that we've seen before, but it deals with what you know about right triangles right now. The diagram below represents the side view of a bike ramp. Which of the following is closest to the value of x? Well, what I've taught you is that anytime you see a right triangle, and we know two sides of that right triangle, this side, and I'm looking for the third side, that we bring up the Pythagorean theorem. A squared plus b squared equals c squared, where the a and the b represent the two side lengths. So A, I'm going to let B 26, and I'll hit squared, plus B would be 6 squared, is equal to C squared. And then what we do is we get our calculator up, and we type these numbers in. Okay, so 26 squared. 26 squared gives us 676. Move that out of the way. 676 plus 6 squared will be 36. Is equal to c squared. So then we're going to add these together. Pull this back up again. 676 plus 36 equals, and we get 712. And then what we have to do with that is take the square root of both sides. So we take the square root of 712. We find out that the answer is approximately 26.7. Okay, so if we look at our answer choices, they gave us everything to the nearest unit, so our correct answer would be about 27. Now, a couple things that we need to understand about right triangles is this third side's always got to be the longest side of the triangle. So you could automatically have eliminated C and D because it can't be shorter than 26, okay, because that's the longest side that we've got right there. Okay, so the answer could only be either A or B. Okay, and we mathematically calculated it out to be A. So let's look at one more question real quick, and then we'll dive off into the first type of triangle that we need to look at. So in this one says, a 10-foot ladder is leaning against a wall. The bottom of the ladder is 4 feet from the base of the wall, as shown below. Which of the following is closest to the distance from the top of the ladder to the base of the wall? So in this particular problem, we know this piece right here, which is one of the legs. We know this piece right here is the angled side, which is our hypotenuse, and the other side that's touching that right angle is going to be the other leg. Okay, so that tells us by looking at this picture that 4 is really going to be the short side. Okay, this one's going to be the long leg, and then what we also know is the hypotenuse. So that means my answer's got to be somewhere between 4 and 10, but it can't be greater than 10, and it's not going to be smaller than 4. So I could automatically eliminate D. Okay? So now we pull up the Pythagorean theorem again. A squared plus B squared equals C squared. Well, the 4 is going to represent our A. I don't know the B, and my 10 is going to be my C squared. Okay, so this one, 4 squared would be 16. Plus b squared is equal to, well, 10 squared is going to give me 100. So then what we got to do is we got to subtract 16 from both sides. So you get b squared is equal to 84. So now we got to take the square root of that. Now I know the square root of 81 is 9. So that tells me that b should be approximately just a little over 9. Okay. So if we look over here, we find out that A is our answer choice. The height that from the bottom to the top is 9 feet. So right now, that's all we know about right triangles, is we know that we can use the Pythagorean theorem in order to do that. Well, today what we're going to do is we're going to look at two such special right triangles. In this particular one, we're just going to look in this video, we're only going to look at one of the right triangles. And I'll make another video for the other right triangle. In this one, it's the 45-45-90 right triangle. Well, in a 45-45-90 right triangle, what we know is this piece right here is going to be our 90. This angle is going to be 45 degrees. This angle here is going to be 45 degrees. Well, what that means is that this side and this side, the two legs, are going to be the same. So if this side right here were 5, whatever units, this other leg is also going to be 5. And I know that this hypotenuse, this side right here, is going to be a little bit bigger than 5. It is our hypotenuse, so it's going to be just a little bit greater than 5. Okay, so those are some things that we know about a 45, 45, 90 right triangle. Well, this is known as what we call our special right triangle because there's some special ratios that we can use. And here they are. The ratios are the hypotenuse is going to be equal to the leg times the square root of 2. So if I know this leg right here, that means all I have to do is take this length and multiply by the square root of 2, and I'll get the hypotenuse. Well, conversely, if I were to know the hypotenuse, all I have to do is divide by the square root of 2, and I will find the length of this leg. So those are two very special relationships that you have in a 45, 45, 90 right triangle. So let's look at a question and see how we can do it and what it is that I'm going to expect you to do on an assignment. Okay, so in this particular triangle, I know the length of one of the legs is 12. I know this leg right here is 12. Okay, so that should automatically tell me what this other leg is. Because if it is a 45, 45 right triangle, then I know my two legs are going to be the same. So you could automatically say that this other leg is 12 meters. Well, what I need to find is x. Well, x is the hypotenuse in this particular problem. So what we're going to do is we're going to look back at the ratio to find out what that is. So hypotenuse is equal to the leg times the square root of 2. Okay, so that's what we're going to do in this particular problem. Okay, so we're going to do hypotenuse, x is equal to the leg length, which is 12, times the square root of 2. So that's what we're going to write. Now, if I wanted to know the exact answer, x is equal to 12 square roots of 2 meters. But most people don't really know how long that really is. So what we had to do then is we're going to find the approximate value. So let me pull my calculator back up. And we're going to take 12 and multiply that by the square root of 2. And we find out that its value, and we're going to round to the nearest tenth, okay, is going to be 16.97. So 16.97. So if I want you to round that to the nearest tenth, that's really going to be 17 meters, because this 7 is going to bump the 9 to a 10, which then makes x 16 a 17. So that tells me x is equal to 17 meters. Okay, does that fit? Yes, it does. Okay, it's just a little bit bigger than 12. Okay, so that's what I'm going to expect you to do on a 45, 45, 90 right triangle if you're looking for the hypotenuse. Okay, so let's look at another one. Okay, so what if I give you this one? Well, in this particular problem, it is a 45, 45, 90 right triangle, and I know the hypotenuse. So what we do is we ask ourselves two questions, basically. What do I know? What do I want to know? Well, in this particular case, I want to know a leg. What do I know? I know the hypotenuse. So we go back to our ratios, and it says I want to know a leg. So I need the formula that says leg equals. And it tells me that to find the leg, I'm going to do the hypotenuse divided by the square root of 2. So what work am I going to do? I'm going to find x. Well, x is going to be equal to the hypotenuse divided by the square root of 2. So I will expect to see that math. Then you'll plug it into your calculator. So you'll bring your calculator. I'm going to bring my calculator back up. Come here, calculator. Oh, and now my calculator's not working. There we go. So 25 divided by the square root of 2, enter. And then again, we're going to round to the nearest tenth. So in this particular problem, it's going to be 17.67, which would give me 17.7, and in this case, inches. So that tells me x is equal to 17.7 inches. Now, what else can you say about this? Well, if x is 17.7, so is y, because both of those are legs. And in a 45, 45, 90 right triangle, the two legs are going to be congruent. So what I'd like for you to do real quick is I want you to work two questions on your own. So I want you to pause the video, And in number 1, I want you to find the length of the hypotenuse. And in number 2, I want you to find the length also of the hypotenuse and this missing leg right here. Okay, so let's find out how you did. So like I said, there's 2 questions that you ask yourself. What do I want to know? And what do I know? Okay, so in number 1, what do I want to know? I want to know the hypotenuse. So that means I need a hypotenuse equals formula. And it tells us the hypotenuse is equal to the leg times the square root of 2. So what we're going to do in this first problem right here is we're going to do x is equal to the leg is equal to, the hypotenuse is equal to the leg times the square root of 2. So we take our calculator. Let me see if I can get my calculator back up this time. And we're going to do 3 times the square root of 2. Enter. And we end up with a value of 4 point, and it says 24, so that means it's just going to be 4.2 yards. So that will be the length of our hypotenuse. Well, in number 2, we're also looking for the hypotenuse. So if we wanted to find x, we know that hypotenuse is equal to the leg times the square root of 2. So again, we take 9 times the square root of 2, enter, and round to the nearest tenth is 12.7, and in this case, centimeters. So this x is 12.7 centimeters. But what if I wanted to know this value? Oh, sorry about that. What if I wanted to know y right there? Because I just put that y in. What if I wanted to know that other leg? Well, in a 45, 45, 90 right triangle, if one leg is 9, so is the other leg. So that's what we do with a 45, 45, 90 right triangle. In the next video, we're going to talk about what do we do with a 30, 60, 90 right triangle. So until then, I'll talk to you later.